In this video, we solve problem 4 of Unit 12. In it, we have two conducting spheres that are initially, they have a certain charge. This is conducting sphere 1 that has a charge of 4 coulombs and it has a diameter of 10 centimeters. And this is sphere 2 that has a charge of 5 coulombs and a diameter of 20 centimeters. So they are put in contact. For instance, we use a wire, a conducting wire, and then they are drawn apart again, and they are asking what is going to be the final density charge of both spheres. Okay, if we know the final charge of each sphere, we're going to easily know what the surface density charge is. So we're going to focus on finding these. And for that, we have to bear in mind that these conducting spheres, once they are put in contact, for instance with the wire, they have to acquire the same potential. So the potential we have here, V1 and V2 prime, have to be equal. So when they are put in contact, there is charge transferred from one sphere to the other in a way that the potential of both spheres is equal. So we have that K Q1 prime divided by R1, which is the electric potential of a conducting sphere with a charge Q1, is equal to K Q2 prime divided by R2. Okay, so for solving this, we need to also bear in mind that the charge is conserved, so that Q1 plus Q2 before they are put in contact has to be equal to Q1 prime plus Q2 prime. Okay, so with these two expressions, we should be able to solve the problem. For instance, we can take expression 2, this is expression 1, we take 2 and we just derive that Q2 is going to be equal to Q1 prime times radius 2 divided by radius 1. This is Q2 prime is Q1 prime times the diameter, the second diameter divided by the first diameter. And this we can use in expression 1. So in 1 we have that the total amount of charge, which is 9 coulombs, has to be equal to Q1 prime plus Q1 prime times D2 D1. Okay, so this gives you that 9 coulombs should be equal to Q1 prime times 1 plus, and this is 20 centimeters divided by 10 centimeters, which is 3 times Q1 prime. So Q1 prime has to be 9 coulombs divided by 3, which is 3 coulombs. So if Q1 prime is 3 coulombs, then Q2 prime has to be 3 coulombs times D2, which is 20 centimeters divided by 10 centimeters, 10 centimeters, which is 6 coulomb. And again, you have that Q1 prime plus Q2 prime has to be 9 coulomb. Okay, so now that we have Q1 prime and Q2 prime, the total surface density charge of the first sphere is going to be Q1 prime divided by the total surface. As it is a sphere, this is 4 pi R1 square, which is 95.5 coulombs per square meter, and sigma 2 prime is Q2 prime divided by 4 pi R2 square, which is 47.7 coulombs per square meter.